Director of Technical Development and Facility of SEDA. Please welcome to the stage. And our third speaker is Prof. Dato Technologies Dr. Kamalzaman Sofian, Director of Solar Energy Research Institute, or known as SRI, from UKM. And our fourth speaker is Mr. Gregors Riemann, Chief Executive Officer of IAN Consultant Siaran Berhad. And our last speaker is Mr. Akram Dandu, Project Leader of UniKL Sustainable Energy Living Lab. Welcome to all our guest speakers to this forum. United Nations did come out with 17 Sustainable Development Goals back in 2015 to create peace and prosperity for people and planet. This forum will discuss Malaysia's readiness to support SDG number 7, affordable and clean energy, and SDG number 13, climate change. The aim of this SDG 7 is to ensure access of affordable, reliable, and sustainable and modern energy to all. And the aim of SDG 13 is to take urgent action to combat climate change and its impact. We are honored today to have a variety of expertise on sustainable energy to discuss further on readiness to support SDG 7 and SDG 13. Our Honorable Minister of Rural Development, Yang Amat Bahagia Dato Seri Mahdzir bin Khalid, mentioned how the Malaysia government is serious about addressing SDG 13 and also SDG 7 to address or to achieve zero carbon by 2050 and also to be able to solve the issue on climate change and global warming. Reminder for all the panel, each of the panel is given about 8 minutes to present your paper, and let's begin this forum by inviting our first speaker, Mr. Masayushi Hayashi, to present on BIPV for Zero Energy Building or ZEB. The floor is yours, Mr. Masayushi Hayashi.
Thank you very much. So thank you very much, and I am very happy to be here today. So I'm Masayuki Hayashi from AGC Asia Pacific. So before the presentation, I would like to explain about this title. The BIPV for Zero Energy Building. So BIPV is standing for the Building Integrated Photovoltaics. So not same as conventional PV, but this is one of the architectural glass material. But in the same time, this is a PV module. So before the presentation, I would like to slightly introduce our company. So AGC is a former the Asahi Glass company. So this is actually the float glass #1 sharing company in the world. Then actually founded in 1907. So already over 100 years since our founding. And our employees are now over 55,000 in the world. So actually, our worldwide presence for example, in North America and South America, also in Europe, and also here, Southeast Asia, and also Japan. So actually, AGC is handling the many types of the solutions for sustainable building and structures. So, for example, the energy-saving glass like Loy-coated IGU and environmental-friendly interior glass, fire-resistant safety glass, and sustainable coating, and anti-stain and paintable sealant, a lightweight, flexible membrane, improve crop growth for the greenhouse. And today, I would like to focus for the BIPB, energy generating glass. So actually, AGC has mainly two types of the BIPB product range. So one is a semi-transparent product, and also another one is opaque solutions. So for the semi-transparent solutions, one is a Vision Square. This is the most standard type. And the second one is a Vision Stripe. This is a very highly transparent type. And next one is an opaque solution. So supply active and outright active and lockability active. So actually, in the new building of the University Kuala Lumpur, actually in the glass roof portion and the facade portion, the Vision Square is planned to install. And also, in the facade with logo portion, the outright active is planned to be installed. So actually, regarding the outright active, so this project is actually the first project to be installed among the Asia. So this is actually very, monumental project also for ours. So AGC is also promoting the net zero energy buildings. So this is one showcase. This is the AGC Kashima plant in Japan. So actually, when energy saving measures and rooftop PV panels couldn't fully achieve the net zero, but BIPV for Vision area could go beyond the requirements after careful study and aesthetic appeal. So in the end, so we could achieve the power reduction of 114%, including the power generation. So actually, for this project, the whole of the facade area, our transparent solution is installed. But thanks to this Vision Stripe, Vision Stripe is actually the BIPV module that can generate electricity without sacrificing the view of the window. So these features allows it to be used on the entire facade without interfering with the building's design concept. So for the architectures, so the possibility to apply the BIPV become increasing. So, and also AGC would like to contribute to promote the net zero standardization. So this is the ISO TS 23764. This is named methodology for achieving non-residential zero energy buildings. So actually, our colleague, Mr. Moreau, conducted ISO TS 23764 promotion seminars for the public and the private sectors in ASEAN. Then ASEAN countries to promote ZEBS as the international project leader of this standard. So actually, the Malaysia also joined in this project team, and finally, ISO TS 23764 was developed and issued on 24th September 2021. So this is a big achievement for the standardization of the zero energy building. So this is the last slide from my side. So at the end of my presentation, I would like to mention about the challenges with the BIPV for building integration. So actually, the BIPV is very unique. It's not a normal conventional PV panel and nor a normal skylight glazing glass. BIPV has both of future it have. And according to this feature, expert advice is required to designing and installation for the actual buildings. So, for example, the customization of the panels, the proposal for the optimal power output, and framing selection and designing, electrical system designing, cable running routing, maintenance, and certification. This is not only for the electrical certification, but also the have to consider the regulation for the building itself, and material selection for the facade, and other design parameters we have to consider. So actually, so we AGC started the business of the BIPV from the 2000. So we have experience over 20 years. So we believe our expertise will sure help on the reducing the future risks after the installation in the buildings. So that's all from my side. So our expertise would like to support your how to say the more expanding designing to the zero energy buildings. Yeah, thank you very much for your attention. Thank you very much.
Thank you, Mr. Masayuki Hayashi, for the very informative presentation on BIPV technology. Definitely, BIPV is the next generation in order to achieve this carbon neutral by 2055, where 2050, where it can reduce up to 140%. So now we know what is the advantage of BIPV. So the next we are going to hear from our next expert from SEDA, technologist Steve Anthony Loh Juting on zero energy building in program in Malaysia. Without further ado, I would like to invite our second speaker to deliver his speech. You may begin, technologist Steve.
Okay, thank you very much, Tuan Moderator, Engineer Muhammad Badrul, and then Yang Berbahagia Prof. Datuk, Datin, Dr. Tuan-tuan, puan-puan yang dihormati sekalian. So my presentation is about the zero energy building. Saya minta maaf terpaksa present campur-campur dalam bahasa Melayu and also in English. My slide is in English. Okay, zero energy building in Malaysia. That's my topic. Okay, next. Oh, thanks, sorry. So, introductions about zero energy building. The first speaker had mentioned about the what is zero energy building. So, to be more specific, zero energy building is advanced, sustainable energy, low carbon building, which is currently being more gain what they call popularity nowadays, especially when the development of target to reduce carbon and so on. And zero energy building is different slightly with compared to the conventional building, because conventional building, they are focus a lot of parameters. But for zero energy building, the metric is on energy, reduce energy and surplus energy with renewable energy. And dia punya performance is quantitative, quantitative. And indirectly also zero energy building actually towards 100% renewable energy used in that building. And the current, we are lucky now, there's already standard of methodology of zero energy building proposed by the Japanese to ISO back in 2018, and in 2020 it was accepted by ISO and become a satu standard methodology. Then also we adopt in Malaysia. And we also what they call work with Japanese Business Alliance Worldwide Smart Energy, JSW, in 2018, and until now we provide the facilitation of zero energy awareness and development program. Next. Okay, zero energy also a global race lah. We're talking about not only Malaysia but also a lot of countries in the world, especially those countries that targeting for lowering their carbon neutral by 2050 and so on. Yeah? Like EU, Japan, even Singapore and Europe. And we know that building sector contribute about 1/3 of the global energy CO2 emissions. This is a fact from the Common Carbon Metric developed by UNEP SBCI. So meaning to say, whatever program like low carbon cities, low carbon neutral building and so on, building actually is the quick wins to offer the high chance to reduce carbon. So macam for example currently Kuala Lumpur targeting for 70% intensity carbon reductions, 2050 carbon neutral Wangsa Maju for example kan. So zero energy building actually is a must to do that. Cuma program tu dalam awareness lagi lah. Okay, this is the definition of zero energy building. Kalau dulu generate solar cover 100%, that is zero. But with the new definitions, the minimum requirement condition ialah the building must reduce its consumption by energy efficiency, minimum 50%. Baru nak qualify go for ZEP ready. And after that, with advances of energy efficiency, energy management plus renewable energy, if when they reach 75% according to apa nama ni, then they reach near zero. Tapi dekat Malaysia kita pakai 70 because under the ISO punya recommendation, it's up to the country punya definition. You want to go 75 or 70, it's up to them. But in Malaysia, we go for 70 because kita align dengan satu lagi standard, we call it Construction Industry Standard 20, CIS 20 Green Pass by CIDB. And then if achieve 100% net, then it's the net zero lah. Kalau dia surplus pun, still net zero. Dia tak ada, belum ada lagi positive zero, whatever. Okay, then most of the country, including Malaysia, target for 45% carbon reduction by 2030 and carbon neutral by 2050. Meaning to say, there's a policy. So policy implementation is actually it cascade down to a few hierarchy lah, from policy and then bring down to the below hierarchy. And normally, kalau dalam perbandaran, we call it low carbon cities lah. Macam Wangsa Maju, they target for carbon neutral 2050, for example. And then bring down further hierarchy sector. They are the building, transportations, infrastructure, and so on. In this case, we talk about building. So this is the low carbon cities framework that developed by Kepada. Now the custodian is KASA. I have chance to involve in this development when I was with Green Tech Malaysia. So if you look there, there ada 4 elemen: low carbon environment, low carbon transportation, low carbon infrastructure, and building. They specifically mention low carbon building, bukan green building, because metric dia carbon. Itu carbon and carbon. So meaning to say, in building, when mention about carbon, in terms of operational, 90% is about energy. So meaning to say, if you reduce carbon in building or towards carbon neutral, you must address the energy by energy efficiency, bagi dia rendah. And then sampai tak tahu lagi, you still use energy and use renewable energy to offset the balance of energy that you need. Okay, under the new definition of methodology of zero energy building, sebenarnya bila kita tengok scan balik projek-projek lama, rupanya memang dah wujud zero energy building in Malaysia. Berbalik kepada bangunan Kementerian Tenaga Leo Building di Putrajaya Pasal F, dulu Kementerian Tenaga dah tukar nama jadi Kementerian Usahawan. So it reduced about 50%, but when I was assigned to monitor, actually achieve about 59. Meaning to say dia dah masuk kategori ZEP ready. Begitu juga dengan bangunan Green Tech Malaysia in Bangi 2007. It's supposed to be a net zero, but because of Ivan Grace was involved there, tak capai because of technology as well as fund lah. But again, it still achieve 86%. So they go for near zero. And betul. Last year, they managed to get award from ASEAN Energy Award on the zero energy on the what they call it near zero lah. Begitu juga bangunan energy commissions. Although it's not designed for zero energy building, it was designed for green building. Dato Architect Nafisa was here. So what happened ialah because of the energy efficiency more than 50%, and with renewable energy it achieved more than 70% reduction, then become near zero di situ. Ini di Shah Alam, Panasonic Green Warehouse. It is failed to achieve green building certification because dalam warehouse, so what inside the warehouse? Macam dewan ni lah, dia ada bumbung, ada apa, lampu, itu sajalah. So dia gagal to achieve the criteria yang banyak-banyak dalam green building. But again, the system lampu, system exhaust was designed to use natural lighting, natural ventilation. By doing that, also energy efficient, and the energy reduced more than 70%. It's also eligible for nearly zero energy building lah. Okay, tadi kita mention pasal building, kilang dan juga rumah. Rumah pun sebenarnya kita dah ada orang kata demonstrations. Ini dekat Putrajaya, buat step by step. In 2010 achieve energy reduction about 64%, and 2017 ada duit sikit tambah solar, and then net zero lah. Sebenarnya to achieve net zero sebenarnya perumahan lah paling mudah achieve, because senang dikawal. Tapi ini tak kira yang dekat Sabah Sarawak yang tak ada elektrik tu, itu memang sudah zero sejak azali. We talking about in the urban environment, environment. Dan juga bangunan UniKL BMI yang tengah naik sekarang. Kita dalam proses certification zero ini, dia mencapai the first net zero energy. Of course dia ada surplus positif. Cuma my CEO tak sempat nak sign lagi kalau tak dapat keluar ini. 5 diamond. Okay, that's the thing. Okay, how to achieve zero energy in the affordable way? Okay, it is about energy efficiency. Kalau kita tengok the energy efficiency and conservation, kalau ada duit buatlah. Tapi sekarang dah ada program. Tadi YB Minister mention pasal company yang offer energy efficiency, audit dan sebagainya tanpa cost. Itulah dia. No capex via energy performance contracting. Okay. Kalau boleh reduce sampai 50%, okay. And then ada juga company offer pemasangan solar tanpa capex. They call it solar leasing SARE, supply agreement renewable energy. Pun ada. These two program can coexist at the same time. Dia sebab dia tak bercampur. Bila dua digabung, itulah dia zero energy at the affordable cost. Is available. Kalau nak tahu macam mana nak buat energy performance contract and so on, okay, dia bermula dengan energy audit. For those want to do energy audit, ada geran. Saya dah ada offer geran kerajaan untuk energy audit di situ. This is a promotion program we started in 2018. All the seminar and so on, kecuali we have signed agreement MOU witnessed by the YB Minister that time. And then kita ada group of zero energy in Malaysia. Dan juga kita ada program training, seminar dan sebagainya setiap tahun, normally every February, but unfortunately during 2020 only online lah sebab pandemik kan, tapi kita buat juga. So 2020 by September later. Okay, mana kedudukan zero energy compare dengan green building? Okay, you look that sebelah kiri adalah the green building, ada duit terus buat lah, ada punya method and so on. But zero energy sebelah kanan. You can start, if you have money, you can straight away, macam UniKL buat dia punya building, ada duit terus buat, or you can do step by step. Existing building pun boleh, tapi ada cara dia lah. Itu yang kita buat facilitation. Macam tadi, for example, kalau setahun jimat 5%. 2 tahun dah 10, 15, 30, sampai 50 dah, you dah achieve dah. Bila sebut zero energy, not necessary to be net. It can be near zero, can be ZEP ready dan sebagainya di situ. Dan assessment, persijilan. Kita ada scan the rating tool. Di Malaysia ada 10 rating tool. Akan datang satu lagi. Malaysia banyak rating tools. But the one and most what they call suitable to rate the zero energy adalah Green Pass. Because it based on quantitative 100% based on the percentage of reduction. Sama macam metodologi yang diperkenalkan oleh ISO tersebut. So Siada dah meet CIDB, kita ambil Green Pass bagi operation. So kita buat satu program persijilan low carbon building dan juga untuk green untuk zero energy. This is dia punya rating. Dia based on reduction. You do whatever you want to do to the building as long as you not compromise with users comfort, safety, quality and law. Asalkan ada reduction and rate kat sana. So if you achieve 70%, you go for ZEP ready. You dapat 70%, you get the near or dan sebagainya. Dan kita dah keluar persetujuan yang itu UTEM. First kali in 2018 UTEM achieve about 57% ZEB ready, dan MBPJ, Astaka, both existing also around 61%, so ZEB ready. So I think that's all about my presentation. Overall, very brief about zero energy building in Malaysia lah. Thank you.
Thank you, Technologist Steve Anthony Lojoton, for the detailed insight by the SEDA on the zero energy plan. And we know that from the presentation just now, back 10 years ago, we already achieved 71%. Most of the building is nearly zero energy building. And I'm proud to announce that by February 2023, we will have Sustainable Energy Living Lab with the 100% of the ZEB, Zero Energy Building. Next, we will proceed with our third speaker, Prof. Dato, Technologist Dato Kamal Zaman Sofian, is a very experienced researcher in solar energy at STREAM UKM, and today is going to present the thermal solar collector for sustainable building. Without further ado, I would like to invite our third speaker to deliver his presentation. A reminder to Dato, you are allocated about 8 minutes to present.
Okay.
Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. Pada hari ini saya akan membentangkan satu presentation yang melihat betapa pentingnya untuk mencapai this carbon neutral sehingga tahun 2050 untuk melihat kepada inovasi dan teknologi dalam tenaga suria. Jadi saya akan memperkenalkan satu teknologi yang boleh menaikkan kecekapannya, kecekapan daripada 20% hingga 80%. Teknologi ini dikenali sebagai photovoltaic thermal collectors ataupun hybrid solar collector ataupun dengan mudahnya PVT solar collector. Jadi ini adalah penting kerana kita kita telah komit pada tahun 2050 kita akan jadi carbon neutral. Kita ada dua cara untuk mencapai carbon neutral. Okay. Kita ada dua cara untuk mencapai carbon neutral. Satu adalah dengan menggunakan offsetting teknologi, kita offset carbon. Atau keduanya, kita mengambil inisiatif tidak menggunakan langsung teknologi yang berdasarkan fossil fuel, berdasarkan bahan api fosil. Jadi tenaga solar merupakan salah satu daripada yang boleh memberikan ke arah di transition kepada zero carbon tadi. Jadi kalau lihat di pasaran, 90% daripada PV itu daripada silicon. In fact, bukan 90%, 95% daripada teknologi yang ada itulah silicon. Teknologi silicon ini, dia mempunyai beberapa ciri. Antaranya, kecekapannya telah pun pergi daripada sehingga kepada 20%, sehingga kepada 23%. Tetapi ada satu perkara yang dilihat kepada teknologi ini adalah apabila dia akan datang dengan berbagai saiz dan yang paling baik sekali adalah yang interdigitated back contact dan sebagainya. Tetapi masalahnya adalah bila dia kena panas, dia akan jatuh kecekapan dia. Jadi masalahnya adalah kalau dilihat kepada spektrum solar, hanya 20% saja yang akan mengeluarkan elektrik. Selebihnya adalah haba. Jadi apa nak guna dengan haba? Jadi oleh kerana itu, haba tersebut boleh digunakan untuk berbagai proses yang lain. Ada yang 10% lagi itu dah hilang, tak boleh buat apa. Jadi ada salah satu daripada teknologi yang boleh menggunakan haba dan juga sehingga 80% adalah teknologi PVT. Terdapat 3 jenis, iaitu berdasarkan air panas, berdasarkan udara panas dan juga kombinasi yang menghasilkan udara panas, air panas dan juga elektrik. Kita panggil dia kombi PVT. Kenapa? Kalau kita lihat, kalau PV panel dan solar thermal digunakan berasingan, kecekapan dia adalah 40%, paling max. Tetapi jika kita gabungkan kerana luasnya jadi satu, maka kita akan dapat lebih kurang dalam 85%. Dan kemudian, selain daripada itu, you also have the advantage of the lifetime. Daripada 30 tahun, you tengok 30 tahun yang selalunya dijaminkan oleh syarikat PV menjadi sehingga 50 tahun. Kerana dia menjaminkan dia membagikan jadi sejuk. Okey. Rasional yang lain adalah jika dia digunakan secara asing, elektrik yang dihasilkan hanya banyak. Tapi apa yang boleh dikatakan dalam rajah ini adalah dia boleh menghasilkan lebih daripada 30% ekstra power. Jadi itulah rasional kenapa kita gunakan teknologi PVT. Ada berbagai contoh. Satu adalah satu perkampungan di Switzerland yang menggunakan semuanya sama kecuali teknologi PV-nya berlainan. Yang teknologi PVT itu menghasilkan 30% lebih lagi power daripada yang biasa. Juga terdapat yang lain-lain. Inilah contoh di beberapa tempat di Spain dan juga di Jerman. Dan ini di Itali, ya, sebuah hotel yang dilengkapi dengan teknologi PVT. Di Malaysia ada satu hospital yang menggunakan teknologi PVT. Dan di UKM kami ada buat satu macam you all buat lah, ni low energy house yang actually menggunakan teknologi PVT yang menghasilkan menghasilkan air panas dan seterusnya menghasilkan juga elektrik untuk bangunan tersebut. Now, teknologi PVT ini bukan hanya yang ada, tetapi inovasi yang dilakukan banyak. Contohnya, dia menggunakan beberapa contoh teknologi yang advance seperti penggunaan nanoteknologi dan sebagainya dalam menaikkan kecekapan PVT tersebut. Contohnya, dalam yang kita lihat ni bahawa bila diletakkan air di bawahnya dan ditambah dengan design absorber yang baik, maka dia boleh menghasilkan kecekapan yang lebih tinggi. Jadi seterusnya, ini adalah satu sistem yang menghasilkan elektrik yang ke grid dalam masa yang sama juga menggunakan air panas untuk digunakan di rumah tersebut. Jadi kita ada satu sistem yang kita buat yang mana boleh menghasilkan kedua-duanya. Seterusnya, menggunakan nanoteknologi boleh menaikkan lagi kecekapan sistem. Ya? Jadi di sini contohnya, perhatikan yang warna biru tersebut. Yang warna biru itu adalah tanpa PVT. Tetapi bila teknologi PVT dikenalkan, kita akan dapati bahawa bertambahan sehingga 30% daripada sumber tenaga yang sedia ada. Dan jika kita menggunakan PCM dan sebagainya, kita juga akan mendapati bahawa kita boleh menaikkan lagi kecekapan tersebut. Bentuk PV itu adalah sama. Dia tidak ada beza dengan teknologi PV yang lain, tetapi dia mempunyai ruang di mana kecekapan tersebut boleh ditingkatkan seperti yang saya terangkan sebelum ni. Jadi kalau lihat teknologinya begitu saja. Yang kita lihat di sini yang kita dah buat daripada generasi yang pertama, yang kedua dan seterusnya yang ketiga, kecekapan tersebut meningkat daripada 60 hingga 70 dan akhirnya mencapai 85%, yang antara yang tertinggi ketika ini. Dan kemudian kalau dilihat kepada ni, perhatikan bahawa jika panel tersebut biasa saja 60 watt, dengan menggunakan teknologi PVT dia naik sehingga 120 watt dalam kes yang desain yang terakhir tadi itu. Maksudnya tenaga dihasilkan 50% lebih untuk kegunaan lain. Dalam masa yang sama dia akan protect the lifetime of the collector. Dan seterusnya ini menunjukkan economics dia. Perhatikan bahawa kalau kita menggunakan sistem yang sama, just PV sahaja, dia mengambil masa lebih kurang dalam 14 tahun untuk modal itu dipulangkan balik. Tetapi apabila you boleh menggunakan teknologi PVT dengan meningkatkan lagi elektrik yang dijual tu, maka you dapati bahawa dia boleh kembali kepada 7 tahun. Maksudnya tidak perlu subsidi. Ya. Hanya dengan menggunakan teknologi PVT sahaja, maka kecekapan tersebut boleh ditingkatkan dan siapa yang ada teknologi ini boleh menjual lebih banyak lagi elektrik. Seterusnya kita dapati dan ini satu contoh yang untuk solar farm, dan kita dapati bahawa jika kita guna teknologi ini kita akan dapat extra cooling dan extra gain energy. Jadi pulang balik modal untuk sistem ni boleh dapat dengan cepat. Dan untuk kegunaan PBT ini kita dapati bahawa dia boleh digunakan bukan hanya untuk sistem pemanasan dan sebagainya, malah dia boleh digunakan dalam sistem penyejukan, dalam sistem pump harbor dan juga dalam sistem-sistem yang lain-lain. Dan akhirnya saya ingin nak promosi buku sikit. Buku yang dibuat mengenai semua yang saya cakap tadi itu adalah buku inilah. Saya dengan itu mengucapkan terima kasih kerana memberikan peluang saya untuk memperkenalkan teknologi ini. Saya rasa one of the kemudian ni rumah yang ada sekarang tu boleh juga diolah pada masa depan untuk memanfaatkan juga teknologi PBT ini. Boleh dijadikan student project, boleh didapatkan funding dan sebagainya. Bukan hanya untuk menghasilkan elektrik tetapi juga untuk menghasilkan kepanasan untuk tujuan tertentu, kalau ada kantin dan sebagainya, dan juga untuk tujuan penyejukan. Okay. Terima kasih.
Thank you, Prof. Datuk Technologist Dr. Kamil Zaman, for a very incredible finding in terms of benefit of PVT, where it seems that PVT can increase the efficiency rate up to from 40% to 60%, and it can increase the power by 100%. So next, I will invite our fourth speaker, Mr. Gengras Lehman from IEN Consultants in Berhad. He will present the UniKL Sustainable Energy Lab, Living Lab, in terms of design concept. Without further ado, I would like to invite our fourth speaker to deliver his presentation. You may begin.
Thank you very much. So I will talk a bit about the design concepts of the Sustainable Energy Living Lab, and then followed by Akram, who will talk about how we make it an Energy Plus building. Oops. So I'll just have one slide on the Living Lab concept. So this is basically that we have designed the building to have 5 identical rooms. So they are exactly the same size. They are all facing south. And then each of these rooms can be fitted with different building technologies. So it could be different solar shading systems, different cooling systems. And then staff and research students can monitor how these different technologies are performing in a real life environment, because this building will be used for teaching. So it's actually sort of real life testing of different building technologies. So this will give a great basis for industry-university collaboration, and this building will be sort of a test bed for many different technologies and be the foundation for many research projects going forward. Then this building is also designed to be highly energy efficient. So as you can see from the sun path here, we made sure to align the building with the sun path. So the long facades are facing exactly north and south, so they can be easily shaded. And then we designed it to be highly daylit, to have natural ventilation where that is possible. And also really to push energy efficiency on all the active systems, so efficient chillers, VSD controls, and daylight responsive lighting, and sort of high temperature cooling, and 3 different thermal energy storage, sorry, not thermal energy, but 3 different energy storage systems. So let me show you the energy balance here. So the column on the left is a building that is built according to the Malaysian standard, MS 1525. But for our living lab, we really squeezed the energy efficiency and managed to make it 51% more efficient. And on the energy storage systems and the energy system in general, this is a diagram of that. So it's actually quite interesting because we have this huge solar PV, and this energy can go to the chiller and produce cooling, but it can also go into a big battery bank and store the energy there. All this chiller can produce chilled water that goes into a thermal storage tank. So there's many different ways to operate the energy systems, and this building can actually be standalone, so that means it doesn't have to be connected to the power grid. So that would be like very useful today because there was a big power cut in the Klang Valley, so this building would actually have been quite okay. I'll just show one slide on the thermal energy storage. So it has 4 big tanks, and there's these manifold pipes and the top and the bottom. So we basically feed the cold water into these tanks, and we design it so the water doesn't enter the tank too fast. So you don't get sort of circulation in the tank, and therefore you get a very good thermal stratification. So that means it's cold at the bottom and then warmer at the top. So that means the next morning, when you have to run the aircon at 8 or 7 in the morning, and maybe there's not enough power from the solar panels because the sun is hardly up, you can basically just run a small pump and draw this stored cool water out to basically cool the building in the first few hours before the solar panels really start operating. But this can be part of the research for the UniKL staff and students to conduct in the years to come. And this shows sort of all these energy flows in and out over a 2-week period. And this building is basically, with all these energy storage capabilities, it's catering to this future where where all buildings have to act like batteries. Because as we go to 100% renewable energy, the energy is not always available at all times. So the ability for our buildings, but also our electric cars to store energy temporarily is basically the future of the building sector and what all buildings have to do. So this building is sort of pointing to the future in that respect. And also on the life cycle cost, of course, it's not a cheap building. You've seen some fancy PV systems, all these energy storage systems. But actually, if you look at it at a life cycle cost perspective, the curve to look at is the green one. So you can see quite quickly the green cost over the years will cross the other 2 curves. So the black one is like a conventional building, and the light gray one is the one built according to the MS 1525 code. And especially once we start paying the real price of energy, which is the graph on the right, then there's a short payback time. So also financially, it actually makes good sense to go in this direction. I think that was my last slide. Yep, I will hand over to Akram.
Thank you, Mr. Gregus, for the presentation just now. So technically, what we know here is that our UniKL Sustainable Energy Living Lab is applying the combination design, active and passive, and the energy saving is around 51%. So lastly, we will hear the presentation from Encik Muhammad Akram Dandu, Project Leader of UniKL Sustainable Energy Living Lab, on how to achieve the Energy Plus. Without further ado, I'd like to invite our last speaker to deliver his presentation.
But the real one will be much, much beautiful, inshallah. So, all right. I just want to brief on our building. So we already agreed to name this building as Sustainable Energy Living Lab. So the size actually, the total floor area actually 2,392 meters squared. We expect to this project will be completed by February 2023. So how we measure this net zero energy building performance actually? So based on this net BI. Net BI actually is the sum of energy consumption of the building minus to the energy generation from the PV panel divided by the total floor area. So based from our calculation, we manage so to get this net zero energy building target. So the value of this net BI should be 0. If we get negative, then it will become net zero energy plus building. So I'm glad to tell everyone that inshallah by 2023 we will have our first net zero energy building in Malaysia, inshallah. The good thing is that because we use the clean energy for this building, so we can also reduce the carbon emission. So it is not, the building is not only achieve 100% natural carbon like a government commitment to achieve 100% natural carbon by 2025, but we already advanced on that. We already achieved not only 100% natural carbon, but we got extra minus 80 ton, negative 80 ton carbon reduction. So I don't know, we can claim this is the first 100% zero carbon in Malaysia as well. I'm not so sure about that. So this is, we use custom BIPV module. We are so lucky that, alhamdulillah, that we can use this custom PV panel. The thing is that this is not a normal PV panel. The normal PV panel actually, you can just generate the electricity. But this custom PV panel, actually you can have this aesthetic, and then you can have this thermal performance, you can have this PV power performance, and things like that. So the roof size is quite huge actually. Imagine that the roof size, our new roof size later on, is something like this. It's a 1,000 meter square. It's very, very huge. And then this roof is not a normal roof, this is a skylight one. So we utilize natural daylighting, 100% natural daylighting during the daytime. So this is the advantage of having this custom semi-transparent BIPV modules. So we also have this lithium-ion battery storage. So we have about 384 kilowatt-hour lithium-ion. So actually, if you talk about this lithium-ion battery, there are many, many chemistry. We can talk about live PO4, we can talk about lithium phosphate, and then we can have this NMC, many, many NMC. So there's a reason why we choose this live PO4 chemistry, but I won't talk on this during this forum. But one of the reason is actually safety, for the safety reason. That's why we use this live PO4 lithium-ion battery. Then we don't use actually NMC. NMC is there was a study that it has this safety reason if you use this NMC, but I won't talk this in this forum. So with this 182 kilowatt peak, we can actually generate more than 220 megawatt kilowatt hour per year. And then another interesting thing for this project, we don't actually, the mounting system, actually we don't use a normal mounting system where we put the railing and then hook and things like that. So this mounting system, actually we use something like million transom stick system. And then the good thing is that we have this structural sealant glazing So how we mount it actually is very, very, very complicated and very interesting actually. So, and also for the, in fact, for this UniKL logo, we have this, we call it rain screen cladding mounting system. So all these new things we have in the building. For this custom semi-transparent, custom semi-transparent PV module, actually we also we don't compromise actually. We don't compromise on the thermal comfort. We don't compromise on the safety. We don't compromise on the PV power generation. So with this, this very okay. This one is a new PV technology actually. Then there's no, actually we are the first in this region actually. We are the first in this region to have this printed PV technology. And the size is quite huge. It's a 9 times 5, 9 meter long and 5 meter width. And then the good thing is that this printed logo or UniKL logo will be facing to the highway. So you can visibly see it clearly, this UniKL logo. And we use actually SC coupled system for this battery inverter, for the grid connected solar PV with energy storage system. We use SC coupled system. So that's the reason why we use SC coupled system instead of DC coupled system. But and then we have this battery, lithium-ion battery. We have this battery inverter. Instead of, if you use DC coupled system, you use solar charge controller. But for our project, we use battery inverter. So, okay, this one, without the, okay, we're almost there. So this is how we achieve net zero energy building target. So this one without the solar panel. Without the solar panel, we already reduced the, we have this energy saving up to 51%. And then with the PV panel for our building, because the PV panel already generated more than 220 megawatt hour. So the energy consumption only 106 megawatt hour. So this energy generation more than energy consumption of the building. So that's why we achieve net zero energy building target. So we don't want that only. We want more than that. We want to be the first in Malaysia to achieve not only net zero energy building target, net zero energy plus building target. So we are making a history actually, inshallah, I mean. So this is how we try to, we will achieve net zero energy building plus building target. Thank you so much.
Thank you, Mr. Akram Dando. So maybe I will try to begin our question and answer session with the panel. Maybe the first question I can ask our panel number 1. Since the SDG number 7, the aim of the SDG is we try to come up with the affordable energy and clean for all. So what will be the challenge for AGC Asia Pacific Limited in order to reduce the price of BIPV so that we see that this BIPV is definitely a future product in order to achieve that carbon neutral by 2050.
Sorry. So actually, now we are promoting proactively for the BIPV for the, especially the zero energy buildings. So we believe this is a, strongly believe that we can contribute with BIPV for the future carbon neutrality. And now we are very struggling to how to expand the BIPV in the world, because of the one feature of the BIPV. So BIPV is actually the fully customized product. So the in this point of view, so the automatically become a high side price. So then how to explain the benefit of the BIPV to the users, and also how to emphasize such a how to say most wide possibility to utilize in the building. So don't compensate the designing of the buildings. So this point that we would like to highlight for the to expand the BIPV in the market, and also contribute for the carbon neutralities. Yeah.
Okay, thank you, Mr. Yusuf. It seems that we still have in pipeline in order to achieve that, but the product is there. It's just that we need to improve. Maybe I'm going to open the question to the floor. If any of the audience would like to answer the question, maybe one question for the floor before I wrap up this forum for today.
I got a question to panel number 3, Prof. Kamuzaman. You mentioned just now, by introducing PVTs, maksudnya with a thermal, that you can improve the efficiencies. What about in terms of cost? How much does it increase the cost in terms of cost compared to the traditional, the conventional PV modules?
Okay, it's about 20% in terms of extra cost, but you are producing 2 types of energy. And also, in addition to that, there's an increase for about 30 to 40% of the electricity itself. As I shown you a graph that shows you the payback period from a normal PV system that only is a grid-connected system. When you have the PVT, the power increases so in such a way that you can get your payback period in 7 years. So the panel have an extra cost, but in addition to that, it will give you more power. And this is how you get back your money from the whole process, the whole system itself.
Thank you, Prof. Maybe one more question from the audience. Dr. Mahir.
Assalamualaikum warahmatullahi wabarakatuh. I have question to TS Steve. Okay, so I think earlier you said that, for example, Bangsa Maju, we have something like zero carbon or low carbon by 2030. So do you have any idea or plan on how to achieve that? Because I live in Bangsa Maju, and as far as I know, there are a lot of development, especially in building, as well as I think that there will be more highways or road to be built around that. So that will increase the number of carbon footprint. So how SEDA will control that, not only in Klang Valley area, but also in other places where a lot of development are going to be introduced to that area, for example. Thank you.
Okay, thank you very much. Wangsa Maju Carbon Neutral 2050. That is the announcement made by the Mayor, Dato Bandar, Dato Mahdzir, early, I think last year, end of last year, in what they call conjunction with the target to make Kuala Lumpur carbon neutral, the carbon low carbon 2030 by 7030. So, okay, the one is now announcement by the DBKL, and for information, DBKL currently work with counterpart from the Japan. We call it IGES, International Green and Energy. What I call it's one research company on that. And also, how SEDA involved, actually, we work with UTM. UTM from the planning, what I call faculty, Pelancaran Bandar, and we actually work on the input on the sustainable energy. So what happened ialah, the carbon neutral 2050 will involve all sectors, transportations, building, industry, even what I call environment. Okay, strategic carbon neutral is slightly different than what we present here. What they do actually, to reduce energy, reduce carbon as much as possible and with renewable energy. But they don't target the net zero energy. Dia target sampai dalam 50%, 60%. The balance offset by the carbon offset from the forestry. That's the idea. Cuma itulah, kalau semua orang pakai offset ni, mana datang offset ni? Because idea of carbon offset supposed to be come from the carbon sequestrations from the hutan lah. Okay, kalau semua orang offset, tak cukup. So the best actually, satu lagi offsetting is involve yearly purchasing the carbon credit. Itu yang biasa bila orang mention pasal carbon pricing, carbon trading, they only mention about one time, but sebenarnya setiap tahun, sebab you use energy every day, every year. So di situ. But we are actually in the process to convince DBKL that not only up to 60% reduction, but up to 100% building if is possible. And the consultant actually buy the idea because it follow the trend, because the consultant also from Japan. The idea like in Japan, they already target for zero energy building. Because if they just want to target low carbon building, even green building, there's no way to get the carbon neutral. Because kita tengok, building representing 1/3 of the energy. If you just target 60%, the balance not enough. Itu baru bangunan, belum lagi transport, belum lagi kilang dan sebagainya. So mana nak beli carbon offset tu? Ideal ialah daripada kredit hutan. Kalau semua orang beli, mana kredit itu datang? So the best is go for absolute carbon reduction on site, bukan main beli-beli. Dia umpama buat dosa, beli dosa, tebus dosa lah. Kan, betul? Buat dosa, nanti kita ada duit, okay, beli tebus kan. So tak jalannya. That is the reality. That's why 2050 jauh lagi. Perancangan kena buat dari sekarang. So we still communicating with DBKL. We part of the committee there. Thank you.
Thank you, Tengah Steve. Maybe last
Tapi
question.
bolehlah sell this idea to DBKL juga. Sebab ada UniKL, I can't remember whether UniKL here or UniKL yang dekat KL tu, they working with DBKL on the wind turbine demonstration dan sebagainya. So, I mean, they actually, DBKL actually accept all proposal and idea that can help them towards carbon neutral. So, di peluang. Dah ada demo ni boleh sell the idea. Become consultant kan. Thank you.
Terima kasih, Teknologi Steve. Maybe last question from audience.
I have the question from Mr. Raymond. So about the cooling system, you say you're using the thermal storage. I want to know which kind of the chiller that you use, which could save the energy in compare with the conventional one.
Yeah, thanks for that question. Actually the slide said it was VRF. It's actually a magnetic bearing chiller. I think it's Daikin chiller we are going for, because this building is not very big. So we are getting one of the smaller ones that still has the high efficiency, and which has an even higher efficiency at part loads. So offhand, I can't remember the brand, but I can, if you approach me afterwards, I can email you. Yep, thanks.
I think we have a very good question answer from the audience. Alhamdulillah, we did have a good discussion on today's forum on sustainable energy achieving carbon neutral by 2050. With the ongoing research and update technology being introduced in Malaysia environment, I believe that Malaysia is on the excellent track to achieve zero carbon by year 2050. On the behalf of the organization and the organizer, I would like to wish many thanks to all the distinguished panel for the excellent discussion. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh. I end this forum and I pass back to Mr. Sejarah Pengurusi Majlis. Sekian, terima kasih.
Hello. Jazakallahu khairan kathiran dan terima kasih kepada Tuan Moderator dan para panelis forum. Majlis diteruskan lagi dengan sesi penyampaian cenderamata kepada para panelis forum kita. Dengan ini, dipersilakan Yang Berbahagia Profesor Madya IR Dr. Muhammad Khairi Rahmat menjalankan tugas Timbalan Presiden Akademik dan Teknologi dan Pengarah Pusat Penyelidik dan Inovasi UniKL serta diiringi oleh Yang Berbahagia Associate Professor Dr. Kushairi Abdul Kadir Dekan UniKL British Malaysian Institute bagi menyampaikan cenderamata kepada para panelis forum. Dipersilakan. Dipersilakan panel yang pertama, Yang Berbahagia Mr. Masayuki Hayashi, Pengarah Kanan Smart Glass Division AGC Asia Pacific Private Limited Singapura.
Seterusnya, panel yang kedua, Yang Berbahagia TS Steve Anthony Lonjuntin, Pengarah Pembangunan Teknikal and Fasilitasi Sustainable Energy Development Authority Seda Malaysia. Dipersilakan.
Dijemput panel yang ketiga, Yang Berbahagia Profesor Datuk TS Dr. Kamaruzaman Sopian, Pengarah dan Profesor Solar Energy Research Institute Seri, Universiti Kebangsaan Malaysia.
Seterusnya, panel yang keempat, dijemput Mr. Gregors Raymond, Pengarah Perusahaan IEN Consultants Sendirian Berhad.
Dijemput panel kelima, Yang Berbahagia Encik Muhammad Akram Dandu, Ketua Projek UniKL Sustainable Energy Living Lab, UniKL British Malaysian Institute.
Akhir sekali, Yang Berusaha IR Dr. Muhammad Badrul Hisham Ismail, Timbalan Dekan Jaringan Antarabangsa, Industri dan Institusi UniKL British Malaysian Institute.
Diminta Yang Berbahagia Profesor Madya IR Dr. Khairi Rahmat untuk kekal di atas pentas bagi sesi penyerahan cenderamata. Diminta Yang Berbahagia Profesor Madya Dr. Kushairi Abdul Kadir bagi memberikan cenderamata kepada Yang Berbahagia Profesor Madya IR Dr. Khairi Rahmat.
Dengan berakhirnya majlis penyampaian cenderamata itu tadi, maka berakhirlah juga majlis kita pada petang ini. Jutaan terima kasih kepada Kementerian Pembangunan Luar Bandar serta para hadirin yang memberikan kerjasama, iaitu dalam memastikan Majlis Perasmian Forum Tenaga Lestari Mencapai Neutral Karbon Menjelang 2050 dan Pelancaran Projek Pembinaan UniKL Sustainable Energy Living Lab ini dapat direalisasikan. Kami selaku pengacara majlis ingin mengucapkan jutaan terima kasih kepada semua dan menyusul 10 jari memohon maaf sekiranya ada terlanjur bicara sepanjang majlis ini berlangsung. Bunga dedap di atas para, anak dusun pasang pelita. Kalau tersilap tutur bicara, jemari disusun, maaf dipinta. Sekian, wabillahi taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.